So with differentiability, what do I mean by differentiability? Does it have a derivative? Like continuous, like continuity. What did I mean by continuity last chapter? Is it continuous? Or was there a hole? Or was there an asymptote? Or was there a jump, right? Those were the types of discontinuity. Today, we're doing differentiability. Does it have a derivative at every point? Okay? Well, why would it not have a derivative at every point? There's a couple of reasons why. So how do we know something has a derivative at a point? How do we know something has a derivative? First of all, it has to be continuous. So it can't be a hole, can't be an asymptote at that point, can't be a jump at that point. If it is any of those, it's not differentiable. So if it's continuous, it's not continuous, it's not differentiable, guaranteed. No sharp turns. So what do I mean by sharp turn? Well, these two are sharp turns here. These two guys are sharp turns. So let's see, let me get so the first one comes down, it's decreasing, right? This one's decreasing, and then at 0, when x equals 0, it quickly makes an abrupt turn, and it becomes positive, right? It goes positive. Same thing here. At 0, as I approach 0, it changes from increasing to decreasing abruptly. So if I did it like this, that's not an abrupt turn. That's not abrupt because you're slowing down, and then it's that one. With this one, you can tell you're slowing, or you're decreasing, but you're not decreasing as much, and then you change to increasing. So it's not necessarily you can't change, it's that you can't change abruptly. So how do we check that? Well, we check it with this guy. This looks similar to continuity, except instead of limits, we use derivatives, okay? So is the derivative coming from the left? So is the derivative coming from the left equal to the derivative coming from the right? If they're the same number, it's differentiable. If they're not the same number, it's a sharp turn. Okay? It's a sharp turn. So like, for example, this guy here. This has got like a negative, let's say -1, right? This guy has this segment here has I don't know if it's -1, but it's definitely negative, right? They don't give me points on here, so I can't really tell, but let's say it's -1. And then at 0, it quickly becomes +1, right? It quickly becomes +1. If you were just given this side here, you're like, oh, it's just negative. But then after, at 0, it becomes quickly positive. That's a sharp turn, okay? So at 0, what is the derivative of that dot? Is it -1 or is it +1? We don't know. So because we can't tell, it fails this rule here. It fails this rule, fails rule 2. It's a sharp turn, okay? Vertical tangent lines. So vertical tangent lines are anything with a tangent line, anything where the tangent line is going to be vertical. Doesn't work either. Why not? Because this has a slope of undefined, right? There's no number for this slope. We have a number for horizontal, but we don't have a number for vertical. So it becomes undefined. So that's why, because the derivative is undefined, okay? So that's what we're gonna check. We're gonna check those 3 things. So they put cuss points and corners. You don't really need to know those names, but why are those made? Abrupt turns, sharp turns. These are 2 examples of things that are continuous, but fail this guy because they have 2 sharp turns at 0. Okay? Both of these guys are continuous. They'd pass continuity, but they wouldn't pass differentiability. Okay? All right. Okay, so here's a quick little box explaining how are differentiability and continuity related. So differentiability implies continuity, but not vice versa. So what does that mean? That means if something is differentiable, if you know it's differentiable at a point, it has to be continuous as well. Because they're going to ask you to do both. They're going to ask you to find, is it continuous at this point? And is it differentiable at this point? Well, if it's continuous, it has to be differentiable. Or if it's differentiable, it has to be continuous. But not necessarily true the other way. If it's continuous, it's not necessarily differentiable. These two guys right here are continuous. If I'm going to draw, I don't have to pick up my pencil once. There's no holes, there's no asymptotes, there's no jumps anywhere. But they're not differentiable anywhere. At 0, there's a sharp turn at 0. So just because something is continuous does not mean it is differentiable. Okay? And then the last one, if it's not continuous, it definitely can't be differentiable either. Okay, so pretty much, how do they go together? Differentiable has to be continuous. Continuous, maybe differentiable, maybe not. Not continuous, definitely not differentiable. Okay? So before we go on from last chapter, how do we know if something's continuous? How do we know, how did we show on the test? In fact, you had questions like this on the last test. I know it was a while ago, but how did we know something was continuous? What did we use to check?
Limit from the right, limit from the left equals
the limit from both sides.
Yeah, exactly, right? The limit from one side, right? The limit as x approaches, we'll call it c, from the left, right, for a function, had to be equal to the limit from the right, positive side of a function. If both of those guys were equal, then there was a limit. If the two-sided limits were equal, that means there had to be a limit at that point, right? And then what did that have to be equal to?
The actual point.
F of c. There had to actually be a point there. Okay, that's what we did last chapter. So they're going to ask us to do that too. They're going to ask us to check continuity and differentiability. Definitely differentiability because that's the new one, but they're also going to ask about continuity sometimes too. So you don't have to do all 4 of those. I think what we did in our notes was we focused on this guy, and this guy. Yeah, I think that's what you can do that. Because if the first two green guys are equal, the third guy has to be equal, right? So that's why you can check all 4 of them, or I think we just check these 3, that's fine. If these 3 are equal, then the one that I didn't highlight, this guy has to be equal, okay? You don't have to check that guy if you do that, all right? Okay, so let's look at example number 1. So determine whether the function is differentiable, continuous, both, or neither. At the value where the rule for the function changes. Well, first of all, where is the value where the rule changes?
The x greater or less than, greater equal to 14 or less than.
At 14, right? At x equals 14, right? That's the only value we're going to check. Why are we going to only check 14 and not anything else? That's where the rule changes, right? If it's 14 or less, I use the top. That's a quadratic. let me highlight this. I use the blue. If it's greater than 14, if the number we plug in is greater than 14, I use the orange. It's linear. Linear and quadratics don't have any continuity issues. Okay, so let's get started. So it doesn't matter which one you start with. You can start with checking for differentiability. You can start with checking for continuity. It doesn't matter which one you start with, okay? Since we had never done differentiability, I'll do differentiability first. Do you have to always start with differentiability? No, you can start with continuity. Okay, so we're checking differentiability at x equals 14, because that's where the rule changes, right? So this said, so how do we check it? Well, we don't have a picture to look at. I don't know if there's a sharp turn at 14. I don't know what's happening at 14. So I'm going to have to do it using what we said on the first. Let's see, what was it? As x approaches c from the left, it has to be equal to the derivative at c as x approaches c from the right. That's what I'm asking, yeah. It's the same setup as limits, except I'm not checking limits this time right now, I'm checking differentiability. So the first thing I need to do, I see tick marks there, right? Primes. That means derivative, right? So I have to find the derivative of the blue and I have to find the derivative of the orange. All right? That's the first thing. So I'm going to rewrite this guy. Where's my... Nope, that's not what I want. There we go. Nope, that's what I want. Okay. Okay, so I'm going to rewrite this, but for f prime now. Okay. So what's the derivative of the blue?
2x plus 7.
Plus 7, right? And it's still true for x is less than or equal to 14. What's the derivative of the orange? 20. And it's still true for x is greater than 14. So when I'm checking differentiability, I'm not going to use the original f of x. I'm going to use f prime. Okay? So let's set it up. So f prime, what is the c value for this guy, the one we're doing right now? 14, right? 14 from the left, 14 from the right. Okay. So I'm going to plug in 14 into the derivative and see if I get the same answer from the left and from the right. So if I plug in 14 from the left side is the less than side, right? I got to plug it into the top, right?
Yes.
Okay, so 14, 2 times 14 plus 7, and I get 35, yeah. Yeah. So what happens when I plug it in to the right side?
Give 20.
Yeah, there's nowhere to plug in, right? I just get 20, right?
35 does not equal 20. Man.
And last time I checked, 35 does not equal 20. So it's not differentiable. It's not differentiable.
All right.
Is it continuous? Yes, no, I don't know. Which one? We don't know, right? We don't know. So let's check it.
You are way too confident.
Yeah, she already did it.
You already did it.
No.
So let's check it. We've done this before. It's not like we haven't done it before. So we're checking continuity at x equals 14. So the limit, so we have the limit as x approaches 14 from the left for the original, right? When we're doing limits, we want the original, not the derivative. Last chapter, we didn't do any derivative stuff. We did the original. Okay. So the limit as x approaches 14 from the left, the limit as x approaches 14 from the right, and then f of 14. If they're all equal, it's continuous. If one of them is off, not continuous. Okay, so if we're checking from the left, that's the blue. So we're going to plug in 14 to the blue. We can't use a calculator, so let's try to do this in our head. 14 times 14 is 196? Yes, thank you. 7 times 14 is 98. Let's see, so 196 minus 78, 118?
I don't. I know.
Wait, minus 78?
Yeah, because I subtracted first and then oh, sorry, plus, right? That's plus.
Yeah.
Sorry, I went the other way. So this is 200. And
274.
74, thank you. Okay. So now plug it into the yellow, or to the orange. 20 times 14 minus 6. See, 10 times 14 is 140, so double that would be 280. Minus 6, 274. And then, yeah, so I would, if for f of 14, you would plug it into the top, right? We already did that, so let's 274. All of these are equal.
You already knew. You already knew.
Okay.
She said no.
I did say no.
Oh, she did not know.
I did not know that.
So let's answer the question.
She said yes.
So, yes, continuous.
Yes, but no.
Let's see. I should say f of x. I should say what is continuous. F of x is continuous at x equals 14, but not differentiable. At x equals 14. So continuous, but not differentiable at 14. Is that possible? Does that jive what we had on our front, on the front?
Yeah,
Uh-huh.
we can be continuous but not differential.
Okay.
We're back to
Okay.
We're back to limits, guys.
All right, so I want you to try number 2. Try number 2, how we just did it. Check for differentiability, continuity, both or neither, where the rule or the function changes. So that's at x equals -2. Which one first? It doesn't matter. Check differentiability, check continuity, whichever one you want to do first, as long as you check both.
Wait a minute. Wait, go through it. How'd you get 42?
Wait, 42.
That right there. Okay, so
I think you added it.
did I add it wrong?
I think you added it.
Yeah, I think you added. Yeah, I don't think you minus 22. I think you added 22.
Oh, okay. That makes sense. Okay.
Because then we got 50.
So differentiable at 2.
Plus 24.
It is differentiable at 2. We both get 7 when we plug in -2 to the derivatives. Differentiable, you got to plug in, let's see, continuity, I'm not sure. Let's see, this side I got 6.
It's a normal 6.
Oops.
Let's see, this side I would also get 6 because -18 plus 24 is 6. This side I would get 6 as well because it's the same as, because I would plug it into the first one, x squared plus 11x plus 24. So all of these guys are equal.
Yeah, those are ugly though.
Oh yeah.
So
I gotta find
we would say
Yes.
f of x is both differentiable and continuous at x equals, not 6, 2, -2.
It's 2-6 brain running.
Okay. All right. It's pretty much the gist of it. Obviously, there's going to be different functions. Sometimes they'll throw in a trig function. Sometimes they'll throw in a natural log. Sometimes they'll throw in things like that. So let's skip ahead. We've done questions like number 3 last time, but let's skip those.
What?
Let's go to the natural log one. Well, let's do these two. Let's go 5 and 6.
Aw, dang it.
Because they're the same type of question we've just been covering.
It's 6 over 10 plus 7.
Okay. So given the piecewise function defined below, answer the questions at the bottom of the page, or just regarding continuity and differentiability. So is it continuous or is it differentiable at x equals 0? That's all they want to know. Okay. Obviously that's where the rule changes, so that's what they want to know. So the first thing we got to do is find the derivative.
There's one of them's like -6. Whatever the derivative was.
So the derivative of the bottom is just -6. That's easy. The derivative of the top, so it's going to be 3.
3 times the derivative of log, natural log of 1 over
So
2
times
x
2 over.
plus 1.
No,
But that doesn't
yeah,
even matter. You get picked out. All right. So it's like
Okay. Yeah, so it's got two terms. 3 times log, or natural log 1 minus 2x, that's the first term, and then positive 1. The derivative of positive 1 is just going to be 0. So really you're just focused on the 3 times the natural log. Okay, so dy over dx equals, so we're going to go, it's going to be 3 times, right? For anything natural log related, the bottom stays the same, the top becomes the derivative. So the derivative of 1 minus 2x is just -2. So you get -6 over 1 minus 2x.
and when x is 0,
Oh,
For x is less than 0.
right, so it's differentiable. So it's nice.
It's differentiable, it is continuous.
Okay? So let's check. Continuity or differentiability, doesn't matter which one you check first as long as you know, as long as you check both. X equals 0.
Check continuity, I don't know.
Oh,
That's where you just.
So the limit as x approaches 0 from the left for f of x is equal to the limit as x approaches 0 from the right, which is equal to f of 0. That's what we did last chapter. So the left side, I would check the less than side, which is the log. So 3 times the natural log of 0, sorry, not 0, 1 minus 2 times 0
okay, so it's just natural log 1.
plus 1. So it'd be 3 times the natural log of
1.
1, yeah. Plus 1, right?
What's the natural log of 1?
That's a great question. What is the natural log of 1? It's a whole number.
It's 1, isn't it?
Rhymes with hero. 0. Why is it? I'll show you why. Because natural log, what does it equal? Natural log is really just log with a base of e, right?
Yes.
So really what they're asking is e to what power makes 1?
Oh.
E to what power makes 1? Well,
Okay.
any power to, anything to the 0 power makes 1, right? So it'd have to be 0. That's why it's 0.
Okay.
So 3 times 0 plus 1, so we get 1.
I think
Okay, so now let's plug it into the bottom. So we get 6 times -6 times 0 plus 1, which is just 1. This guy will also be 1 because I would plug it in again to the bottom. Continuous. Do we have to check differentiability or can we assume differentiability?
No.
Yeah, we have to check it. We have to check it. Because continuity could go both ways. It could be differentiable or not differentiable. Okay, so differentiability at x equals 0. So we need to use the derivatives. F prime of 0 as x approaches 0 from the left has to equal f prime of 0 as x approaches 0 from the right. Plug it in 0 again, but this time I'm not doing it to the original, I'm doing it to the derivative. So -6 over 1 minus 2 times 0, that has to equal -6. Negative 6 over 1 equal negative 6 every time. So we would say f of x, that equals, is both differentiable and continuous
Funny way of saying one.
at x equals 0. These are big time FRQ questions. You're going to have something where they ask you about continuity and differentiability on FRQs. Okay, these are almost always FRQ questions.
Huh?
With all
Mhm.
is this.
Oh, yeah.
Do we have to write f of x is
You write one more
differential
exercise.
and continuous, or can we just provide the work?
So if you just provide the work, I have no idea what I'm looking at because you haven't answered the question. So yeah, you got to answer the question. Yeah, I would say always answer the question. The work backs up, right? But yeah, always answer the question in words. For full credit, yeah, I would do that. Okay. All right, so I want you to do number 6 now. Do number 6 if you haven't already started.
Can I go to the back?
Yeah, go ahead. And number
Did you
6.
make me or?
I got you. Is number 6 on yours the last question? Or is there another page?
There's another.
Is there another page? Okay, because yeah, it's labeled. I don't know why it's labeled that way.
Yeah, it goes 6 and then 2 and 3.
Yeah, but 3 and 4 are finding A and B.
So,
Oh my god. Please just write 2.
So yeah, this one is both differentiable and continuous. You get the same. Okay.
we did not get any of that.
So the only other questions. So actually I think the last page is
like,
just extra
yeah,
questions
just like find A and B.
that I put on there. So if we have time, we'll do those tomorrow. But I want to go back to the questions we skipped, which were 3 and 4.
These are the not fun ones.
Yeah, so you guys have done these before. Just with the only ones you did them with were just continuity. But now we're also doing it with differentiability. Because this one says it is differentiable. They've already plugged in -2 and they've checked it is differentiable.
99.
Okay? So we have to figure out what A and B are to make it true. So what would I plug in to make it true so that it is differentiable? Well, if you're checking differentiability, I need a derivative. So the first thing I got to do is find the derivative. So what's the derivative of 3ax plus 3?
3A.
3a, yeah, 3a. Because A and B are not variables, they're numbers. Okay, they're values. Well, x is a variable, is a number too, but it's a variable. Okay, so 3a for x is less than or equal to -2. What's the derivative of 2bx squared minus x minus 3?
4bx
Keep going. 4bx, good.
minus 1.
-1, good. Okay. Do the same thing you did, except we're only plugging in for x. We're not plugging in for a and b. So don't think you have to plug in for a and b. We're trying to figure out what a and b are. Okay, so it says it's differentiable. So if it's differentiable, they should equal the same thing from the left and from the right. So let's check. F prime at negative 2 from the left better be equal to f prime of negative 2 from the right. So from the left, I'm going to use 3a. And there's nowhere to plug in negative 2 because there's no x. So it's just going to be 3a. From the right, I would use 4bx minus 1. There is an x there, so I can plug in negative 2 there. So you get negative 8b minus 1. But that doesn't help us solve what a and b are. If you remember from the last chapter, we need two equations that we could do elimination with. So where are we going to get the other equation? Differentiable, because if it's differentiable, it's going to be continuous. Okay? If it is differentiable, it's going to be continuous. So let's track continuity at x equals negative 2. So the limit as x approaches negative 2 from the left for the original f of x has to be equal to the limit as x approaches negative 2 from the right for f of x, which has to be f of negative 2. So do the same thing, but plug in negative 2 to the original. So if I plug it into 3ax plus 3, it's going to be 3a negative 2 plus 3. So that's negative 6a plus 3. And then if I plug it into the right, I plug it in twice. I plug in x twice. Squared minus negative 2 minus 3. So negative 2 squared is 4 times 2 is 8b plus 2 minus 3. So 8b minus 1. So I have one equation there and one equation here. Okay? So you have two options. Last chapter we used elimination. You can use elimination. Substitution is another one. I wouldn't suggest graphing it. Graphing's the other one. I would suggest using. So to use these, you have to have A and B on the same side. So we're going to have to do a little bit of prep work here. So for this guy, I'm going to have to add 8b to both sides. So I get 3a plus 8b equals negative 1. And for this guy, you're going to have to, you can subtract 8b or add negative 6a. And then I'm going to, let's see, I'm adding over here, so I got to subtract 3 from both sides. Okay. So you're going to get negative 4 over here. And over here, you're going to get negative 6a minus 8b. Those are the two guys I'm going to stack against each other. So you know what? I'm going to take this to a separate sheet of paper because I'm running out of room here. Okay. So far, this is what I got. I'm going to take both of these guys and move to, this is example 3. Okay, so I have 3a plus 8b minus 1 equals negative 1. And then I have negative 6a minus 6b equal 8b, sorry, negative 4. Well, it's already set up for elimination because when I add straight down, the b's are going to go away.
Yes.
So it's negative 2a equals negative 5.
2.
Oh, sorry, 3. Negative 3a equals negative 5. Divide by negative 3, divide by negative 3. A is going to be positive 5/3. Plug A back into anywhere. You could plug it into f of x. You could plug it into f prime of x. You could plug it into the one of the new one. It doesn't matter which one you plug it into. Plug into anything with an a and a b. Well, I guess the first two guys, the f of x doesn't have an a and a b together, so you would have to plug it into one of these guys down at the bottom. 3a plus 8b minus 1, or negative 3a minus 8b minus 4. Plug it into one of those guys. So we got 3a plus 8b equals negative 1. I'll plug it into one. I'll plug it into the first one. 5/3. So it would just be 5 plus 8b equals negative 1, because the 3's will cancel out. Subtract 5 from both sides. Divide by 8. You get negative 3/4. Done. So we've done these, but just not with differentiability. We've did them with continuity. But essentially, it's the same thing. So that's why I was going a little fast, because hopefully it looked a little familiar. Okay. All right, so tomorrow we'll finish. We'll finish the notes tomorrow. That last page, I'm not sure. We might do one of those problems. We're not going to do all of them. I'll probably give you just one of those to do, or not. I'm not sure yet. It depends on how much time we have tomorrow. But yeah, so we'll definitely finish number 4. Definitely finish number 4. And then, like I said, I might give you those, or I might let you start on the practice. I'm not quite sure, but yep.